Okay, so today what we're doing are quadratic inequalities and solving system of linear and quadratic equations. Okay, definitely important. And what I wanted to do to start off is we are not going to do it the way the textbook shows it. Okay, there's an easier way to do this, much easier way, and it's the way that we do it in calculus on the AP exams. Okay, so if you go home and sometimes you click on these notes at home and you try to see how they did it rather than watching the video and seeing what we did in class, please understand that I'm showing you something totally different than what the textbook is showing. Alright, so my method of solving this inequality, and just review, it is an inequality because there's no equals sign right there. Okay? It's all about pretending. Okay, we are going to begin by pretending that this is equal to 0. So we have 2x squared minus 14x, and we're going to pretend that it equals 0. From here to solve, I would just factor. Okay, what's the GCF that you see to factor out right now? 2x. So you would pull out a 2x. The leftover scraps are x minus 7. And those are your two factors that are multiplied right now to equal 0. And the reason why I wanted to pretend on this is because anything times 0, anything times 0 will always equal what? 0. The only thing that doesn't work with is infinity. But you don't learn that until you go to calculus. Okay? Anything divided by 0 is always what? Undefined. I wanted you to know the difference. Anything times 0 is 0, but anything divided by 0 is undefined. The only thing that it doesn't work is this, and again, you learn that in calculus. My point to this is, if anything times 0 equals 0, that means if I can solve when this piece is 0, that's one of my answers. Because green times orange would equal 0. Y'all with me? Do y'all see where I'm going with that? And if I solve orange's answer for 0, then that's one answer as well, because orange times green would be 0. So I'm really looking at two little pieces. We've been doing this. Setting each factor equal to 0 and solve it. Everyone. What's my first answer right here? 0, right? Because I divided by 2. Alright? Anyone. What's my answer to the one over here? X minus 7 equals 0. 7. So x is equal to 7. I have two answers right now that if I were to graph them on a number line, I would put 0 and 7. And let me ask you this. Would it be a closed dot or an open dot? Open dot. It would be open because we were only pretending right there. So we could find these numbers and find them quickly. And now they're going to be open. So we'll put open dots here and here. And now I just got to figure out where to shade. Because inequalities, it's all about shading. Okay, so we're going to do something. This is the method that I prefer you guys to do because we do it in calculus. Are sign tests. We're looking for when is it positive and when is it negative. Okay? And the way we do this is we're just going to test. Let's test the waters per se. We're going to test and see what signs are in those intervals. Is it positive? Is it negative? So I only have to test 3 intervals, and I only have to grab one number. Okay, let's say that we want to grab a number to the left of 0. What could I say to the left of 0? Negative 2, negative 1,000. The easiest one I would say is probably negative 1. Okay, because it's small. And if I put a negative 1 here, negative 1 times 2 is a negative 2. But all I care about is that it's negative. I don't care what number it is. All I care is that it's negative. And if I put that same negative 1 test point right here, what's negative 1 minus 7? Negative 8. But all I care about is that it's what? Negative. Because what's a negative times a negative? Positive. That's how I'm going to know the signs like this. Okay, I'll do it again. Notice, I'm plugging it into the factored form. Don't plug it into the original because it takes forever to figure this stuff out as far as is it positive or is it negative. I don't care about the number. I just care is it positive or negative. Alright? So anyone, between 0 and 7, what number could we choose? 1. We could choose 1. We could also choose 6, but I say keep it small. Right? So if I put 1 right here, what's 2 times 1? Positive, right? If I put 1 right here, what's 1 minus 7? Negative. So what's a positive times a negative going to give me? A negative. One more interval to test. What number should we throw in there? 8. If I put 8 right here, 2 times 8 is positive. If I throw 8 here, 8 minus 7 is positive. So if I multiply these, it will be positive. And the reason why I did this is because at the very, very beginning, it looks difficult. But if you do it this way, you break it down much, much easier. All you've been looking for is when it's negative. That's it. Less than 0 means negative. Okay? So negative here is going to be between 0 and 7. And you could also write it.
Wait, we said that less than 0 is positive.
No, less than 0 is negative. No, okay, I see what you're saying. So less than 0 as far as written here in my original equation means I'm solving for when is this equation negative in the original thing. Our test intervals,
I get what you're saying.
when it was less than 0, gave a positive answer. Okay, so yeah, I could see how there could be confusion there. Just make sure you understand what this sign test represents. Yeah.
So when you find the signs like positive or negative, then so like for this one it's less than 0, then it would be like
All the negative, we're looking for all the negative answers.
oh.
You know what I mean? So in the original one, let's go to the original one. Instead of less than 0, if it said greater than 0, we would look for all the positive answers.
Oh, okay.
You see what I'm saying?
So because it's less than 0, then you would look only between where it's negative.
Negative, yeah. So let's say it was equal to 0. It would just be right there, and they would be closed in. Thanks for the question, because that's perfect. Right there you saw all 3 case scenarios. If it was equal to those points and they're colored in. You see what I'm saying? Okay. Any questions? Alright, so let's get another practice and then we'll go bonus points. So our next practice we're going to look at together is this one right here. So 4x squared minus 36x. Okay? And it was saying is greater than 0. And the way I want you to read this is, when is this graph positive? You're with me? That's really all we're doing. So if I looked at that, let's go ahead and factor. What do we have to factor out? 4x. What's left over scraps? X minus 9. And then it's positive. Okay? Again, for the purpose of quickly getting my answers, I'm just going to pretend it says. Pretend. You're going to change it back. But pretend that it says equal to 0. So that what are my 2 answers right here? 0 and 9. Perfect. So I will write out my number line, 0 and 9, and then test the points and see what I get. You with me? So let's test something in the factored form in my first interval. Drew, what would you test in that first interval?
The first one I had
Negative 1. All right, so with me, Drew. Negative 1 here gives me a negative. Negative 1 here gives me a
Positive.
what's negative 1 minus 9?
Negative 10.
Negative. So two negatives, anyone multiplied together would give me what? Positive. I see where you're going. So the whole interval is positive. Okay? So everyone with me, let's do this together. Our next number that we could test is what? 1. So here we go. Plug in 1, I get a positive. Plug in 1 here, I get a negative. So the answer is negative. Because a positive times a negative equals a negative. Okay, let's do this together again. Let's try the number 10. We're testing out this last interval right here. So if I plug in a 10, everyone, I get a positive. If I plug in a 10 here, I get a positive. And the multiplication gives me a positive. Remember, I'm looking for the positive answers, and only the positive answers. Okay? So my answer here would be negative infinity, and I want you to do both when we do bonus points for the next question. Negative infinity to 0, union 9 to infinity. And I want you to do both notations. I want you to do this notation, and I also want you to do that notation, the inequality notation, the algebraic notation. Yes?
Should we start with the difference of squares when we always get positive, positive on our number line?
So, however you end up factoring, no matter what you do, I'm wanting you to do that number line test no matter what. So you have 5 different forms of factoring. Whatever it is that you choose to do is going to help you get these points. Okay? And then everyone, like you could do completing the square, someone can do factor by grouping, someone else can do the quadratic formula. Whatever y'all do, you're all going to get these points in the end no matter what. And then you all kind of come back together and you're going to sign test it anyway. And these are only sign tests of when this right here is something other than equals.
So if it's equal to just go to
If it's equals, you just go for these, you're done. But if it's greater than, if it's less than, or if it's greater than or equal to, or less than or equal to, you're going to do all this that we're learning today. Okay? Let's pretend that this said greater than or equal to. Okay? The very original one, it says greater than or equal to. How does it change my answers? Yeah, you color in the circles. And Alex, what do you do also?
You put the line, the equal sign on.
Perfect.
and you have brackets.
And you have brackets. Nicely done, guys. Nicely done. That's the only thing that changes. But the intervals are the same. You see what I'm saying? The shading is the same. The sign testing is the same. Are we good? Okay. So I'm going to pause the video. We're going to go here in just a bit to your first problem that you're going to get for bonus points. Let me show you the problem first, and I'll give you, we'll go 4 minutes. 4 minutes to solve it out.
We got more paper notes.
Yes, we have more paper notes after this, just a little bit. We're going to do systems of equations. But you have 4 minutes in your groups to solve this, and I gave you 4. Next problem, I can only give you 3, but so that you can talk. Go for it. So here's the breakdown. Each of these circles is points. And notice how I wrote my answers in interval notation and algebraic notation. So picking up this pace a little bit, we're going to solve the next one in 3 minutes. Still the same, you can put it on your board. Let's go with, where is it at? This one's a little bit different actually, so I'm recording it, no worries. So the way we just did that problem was straight up solving inequalities.
Do I need my notes?
Okay, so get your notes back out real quick. This is where your notes are going to go, and then I'll give you a mixture of both here at the end for bonus points. So these are solving a system. So if you see solve all by itself, most of the time, what variable are you solving for? X. But if you see solve a system, you're not just solving for x, you're solving for what? X and y. You're solving for the points. You're solving for what is x, and when I plug it back into the equation, what is y? Because you got to give both. Okay? So just keep that in mind. Here we go. I have all of this equation right here. Negative x squared plus 5x plus 6 is equal to y. I have x plus 6 is equal to y. So if those are both y's, I can substitute this right here so that I'm solving this system. Okay, and you're probably doing some of this for sure in your work with the project when you do this by hand. Okay? Now, what I'm about to do right here is important because if you do it a certain way, your mistakes are limited. If you do it a different way, you're more prone to making negative mistakes. And the number one mistake in calculus is negative mistakes. The number two mistake is parentheses with distribution and stuff. So I want to build some good fundamentals right now with you. If you're the type of person that would move this over and move this over, leaving this biggest degree of x negative, chances are you're going to struggle with this. But if you're the type of person that always tries to keep my biggest coefficient of x positive, even throughout the equation and all that solving, then you don't struggle with this as much. Okay? So my point is this. I think to limit mistakes, you should move this to the left. So that your biggest power of x, that coefficient in front of x, is positive. Here we go. So what would I get? X squared, move everything, right? Minus 4x, nice speed, is equal to 0 because the 6's cancel out. Okay, so now the negative mistakes are going to be reduced significantly. And remember, if this was an inequality and I divide by a negative, I have to flip the inequality. A lot of people forget that. So the move I just made is, in case you forget to flip something like that, you still get it correct. Okay? All right, help me out from here. What do I do? Factor it. GCF is what? X. Scraps? Perfect. Minus 4, right? So now each one, I have two of them. X equals what? 0 and 4. Nice speed. So I'm not going to do a number line with this one. Why am I not going to do a number line and test the signs with this one? Because it's equal to. There's no inequality here. There can be. Sometimes there can be. And there will be. But for the equals ones, we don't have to test the signs. Okay? So, are these my answers? They're half of my answers, right? Those are the x's to my answers. I need the full point. So I need to plug these back in to see what are the y values. Which equation am I allowed to plug these back into? Any of them. I could plug them in the top one, which is probably a little bit more work. Or I could just plug them into the bottom one, which is easier. Let's plug it into the bottom one. What does 0 give me? 6. What does 4 give me? 10. And those are my answers. Otherwise, when you plug in stuff, you're going to have to be careful with parentheses. Let's say we plugged in a 0. And a lot of this test will be non-calculator. And this is where a lot of mistakes happen. Let's say that we plugged in 4. Let me show you what I'm talking about. Right here is where a lot of mistakes will happen when you're doing it by hand. What does that equal? Negative 16. Okay? What does this equal? Positive 16. Finally, what does this equal? Negative 16. Because PEMDAS says the exponent is done first, which would give us a 16, and then multiply by that negative to give me a negative 16. Questions? Yeah.
Just write -4, so when you do -4 to the exponent,
Wait, what?
because if you write down -4, why don't you just do -4 to the exponent? Why do you have to multiply the negative afterwards?
Because PEMDAS says this. PEMDAS is parentheses, exponents. This is order of operations. Multiplication, division, addition, and subtraction. This is the order of operations. So if I see something like this, I don't see parentheses, but I do see an exponent. The exponent that I see is here. So whatever is immediately glued to that, you do that first. So you get 4 squared. Then multiplication, and he's not alone. A lot of calc students at the very beginning, I'm not sure how they don't realize this earlier on, but the multiplication would be done afterwards. So that answer, and you can test it in your calculator, will give you a negative 16. Okay? But if we did it this way, with parentheses, parentheses are done first, and then the exponent. So this -4 squared is really this. And a negative times a negative is a positive. That is a common mistake. That is a big, big common mistake. All right, so now we're going to go for points, okay? Remember all the work that I'm looking for? Remember if it's equals versus an inequality. And here's your problem right here. Negative x minus x plus 6. Sorry. Negative x squared, for those of you in the back, minus x. You're still doing this as a full group. And then we'll do x plus 3. This time let's go for 3 minutes. Solve the system, show all steps. Here we go. All right, time's up. Let's see how well you did setting these equal to each other. I was definitely looking for that first. The second step was, let's get them all on one side. So x squared plus 2x minus 3 is equal to 0. Then x plus 3, x minus 1 factored out. And since this is only looking for the equals, I get a 1 and a -3 answer. But because it's a system, I got to plug them back in. I'll use the easier one and get 1, 4, and -3, 0. So my answer should have been, here we go. So there's 1, 2, 3, and then we'll go 4, 5. You must have the x and the y.